9. An explosion at ground level leaves a crater with a diameter that's proportional to the energy of the explosion raised to the 1/3 power, or the cubed root. An explosion of 1 megaton of TNT leaves a crater with a 1-kilometer diameter. Below Lake Huron in Michigan, there appears to be an ancient impact crater with a 50-kilometer diameter. What is the kinetic energy associated with that impact in terms of A, megatons of TNT, and Hiroshima bomb equivalents? All right, so let's take a look at this. What are we given? We're given that the power raised to the 1/3 power is proportional to the diameter. Now, we don't know what the constant of proportionality is, but we can use that to set up a simple ratio. We know that if you've got a given power raised to 1/3 power, it produces a diameter of D1, and this one would produce D2. It's directly proportional, and so we can set up a ratio like that. If we do this without figuring out a constant, we can actually solve this one fairly easily. What do we know? Well, we know 1 megaton raised to 1/3 power produces a 1-kilometer diameter crater. And we're trying to figure out what power raised to 1/3 power produces a 50-kilometer diameter crater. The beautiful thing about this 1 raised to the 1/3, I'm going to leave out m here and just assume that this power up here is also in megatons. 1 to the 1/3 power is, of course, 1. And I'm going to drop the units here again just for convenience. And that just gives us this. The power on top, p1 to the 1/3 power, is equal to 50. And I'm leaving out units. And please realize the power we solve here then is going to be in megatons. Cubing both sides, we discover that P1 is 125,000 megatons. For those of you who are thinking, that is 125 gigatons. All right, that's the answer to A. B asks, all right, how many Hiroshima bomb equivalents is that? The Hiroshima explosion was about 13 kilotons of TNT, or equivalent to that, somewhere between 10 and 13. We'll assume it's at the upper end 13. And if we do that, you could do some quick conversions. First of all, we have to convert megatons to kilotons. So remember, 1,000 kilos would be equal to a mega. And each Hiroshima was equal to 13 kilotons. If you can't quite see it yet, units work out nice. Megatons cancel out megatons, kilotons with kilotons, and this will give us the number of Hiroshima bombs. The answer is something crazy, about 9 million Hiroshima equivalents. That is the answer to B, and it is an absolutely absurdly large number. Yes, it would not take a very large asteroid to produce that, but it's still a crazy amount of experiment or explosion or amount of energy released at one time, at one instant. I hope this helps. Good luck.